Welcome to lesson 81, Relations and Functions Part 2. So this lesson goes hand in hand with lesson 79. 80 was on in the middle because it showed you something that you need for this lesson. So let's get into it. Here's our objective, vocabulary. This is a graph for you to read through, rules and notes, what a vertical line test is. So we're going to talk about the graphic nature of functions in this lesson. So that's how this is different. So in the last one, you looked at tables and values, you looked at domain and range, but now we're going to look at the graphic nature of functions. Okay, so let's look at our first example. Jose studies temperature trends on animals. Some of his data are in Fahrenheit and some are in Celsius. How can he relate the data? So basically, what you have in the middle here is the calculation to go from Celsius to Fahrenheit. So Fahrenheit is your input and Celsius is all alone, so that's your output. So 212, so let's show you how to work this. 5/9 times 212 minus 32 gives you 100 degrees Celsius. 5/9 times 98.6 minus 32, and then 5/9 times 32 minus 32, any number times 0, 0, and then 5/9 times 0 minus 32. So I'm going to put this in my calculator and do 5 divided by 9 in parentheses, and then 98.6 minus 32 in parentheses, and get 37 Celsius, and then negative 17.778 degrees. Because we're doing algebra, we are going to round everything to the third digit behind a decimal, the thousandth place. I could have left it at 18 degrees, but when you divide by 9, usually your numbers will repeat. So these are some typical numbers we should be aware of. 98.6 is body heat, 37 Celsius, 212 degrees Fahrenheit is the boiling point of water, 32 degrees Fahrenheit is the freezing point of water on a Fahrenheit scale, which is not based off water. The Celsius scale is based off of water, and so the numbers look a little different. So when you say 0 degrees Fahrenheit, you're something different on Celsius, and the rest of the world use Celsius, and so does science. So we saw this putting our inputs into the expression and getting the output in the last lesson. Okay, so let's look at example 2, and let's line up what we have. We have -2, -1, 0, 1, and 2. So in a point, whenever you see a parentheses and two numbers separated by a comma, the blues are X. That's your input. Your output is your Y, your reds. So we see 0, 0. We see -1, 1. We see +1, 1. We see -2, 4 and +2, 4. So each domain goes with one range. So if I was to draw this differently, and I had 0, 1, and 4, I see -2 and +2 going to 4. I see 0 going to 0, and 1 and -1 going to 1. So this is possible. You can have two different domains or two different inputs or x values going to one output. So that's good. You can have 2 going to 1. You can't have 1 going to 2 or more. So this is okay. So this is a function. All right, evaluate the function and write the ordered pair. So f of x equals 3x minus 4. Find f of -4. So since it is f of x, this is our x value. This is the number we substitute in. So our coordinate point will be -4 and whatever our output it is. So f of -4 equals 3. We always substitute using parentheses to keep our signs straight. 3 times -4 is -12 minus 4. So f of -4 equals -16. So our point is -4, -16 for this function. And so those were our examples. Please try to practice problems, and I will meet you at the end of the lesson. Okay, what is the domain and range of each relation? So the domain is 4. That's the domain. And a range set is 0, 1, 2, and 3. And so 4 goes to 0, 1, 2, and 3. This is not a function. A domain cannot go to more than one range. Evaluate the function and then write the ordered pair. X plus 1 squared. So our ordered pair is -2 is our x. F of -2 equals -2 plus 1 squared. -2 plus 1 is -1 squared is +1. So there you go. That's our ordered pair. And then finally, problem 3. So we did not deal with any graphs in this lesson, but it will be coming up in a future lesson. So what is the range of the function? The domain is this set. So we're going to start with f of negative 2. 5 times negative 2 plus 1 gives us negative 10 plus 1. F of negative 2 equals negative 9. So let's do f of negative 1. F of negative 1 equals 5 times negative 1 plus 1. Negative 5 plus 1 equals negative 4. And then let's do f of 0. F of 0 equals 5 times 0 plus 1. 0 plus 1, which gives us 1. So our domain is the set negative 9, negative 4, and positive 1. Okay, so the domain and the range. And so that is our relations and functions part 2. So we look more at the algebraic, the solving of an equation part of it. The graphs will be coming up soon, so don't worry. All right, so if you like what you saw, subscribe to this channel and hit that notification bell, share it out, tell somebody about it, and I will catch you on the next video.